You know, everyone in the AI space is obsessed with autonomous agents. The big dream, right? A level 4 system that can just take any problem and run with it all by itself. But for anyone who's actually trying to build and ship a real product, there's a much more important question we need to answer. So, are we really building a revolution here, or are we just creating these incredibly complex, expensive ways to burn through venture capital on agents that just get stuck in loops? Today, we're going to dive deep into what I call the autonomy trap, and we're going to see why the real progress and, frankly, the real money is in a totally different kind of agent. Okay, so to really get the trap, you first have to appreciate the dream. I mean, the vision of full autonomy is so powerful for a reason. You have researchers out there pushing the absolute limits of what's possible, and they're creating systems that are, genuinely mind-blowing. Take a look at this number, 590. So what is that? Well, that's how many individual AI agents a single system managed to coordinate, all working together completely on their own to generate national policy simulations. We're not talking about a simple task here. This was a massive, incredibly complex undertaking. And the system that pulled this off is called Mega Agent. It's built to take these huge, hairy goals, break them down into smaller pieces, hand them off to specialist agents, and just monitor the whole thing, all without a human needing to spell out every single step. This is it. This is the peak of that level 4 autonomous dream. But here's where it gets really interesting. What the Mega Agent research uncovered about everyone else. And here it is, the reality check. The very same paper that showed us this incredible dream also put other very popular autonomous frameworks to the test. And the results? Well, they were not great. It turns out that that dream of autonomy can turn into a total nightmare of failure really, really fast. And this is a direct quote from their paper. When they tested other agent frameworks on a pretty complex software development task, they found that they either spat out useless junk or they just flat out failed. So the huge question is, why? Oh man, this just says it all, doesn't it? This is the actual output from the Agentverse framework when it tried to build a simple game. Bad score, reject. That's what it came up with after 10 tries. And it wasn't just them. The researchers found that AutoGen got stuck and gave up, producing incomplete code. MetaGPT got caught in these infinite loops, or sometimes just built the wrong thing entirely. So what is going on here? How did one system succeed where so many others just fell on their face? Well, it all comes down to a really fundamental difference in how these agents are designed. It's like a tale of two completely different philosophies. So on one side, you've got what we can call probabilistic agents. Think frameworks like AutoGen. They're event-driven, almost like a chaotic group chat with AIs, and that's great for brainstorming. But when you give them a complex, multi-step job, they just lose the plot. They forget what they've done, they repeat themselves, they get stuck. But on the other side, you have stateful agents, like the ones you build with LangGraph. They use a structured graph-based workflow. Every single step is tracked, the state is saved. The whole process is predictable. It's designed for production. So let's really dig into why this stateful approach is the key. Why is this the thing that lets you escape the autonomy trap and build agents that actually work reliably every single time? It's all about creating a durable, predictable process. Okay, the secret sauce to statefulness is this idea of a checkpoint. And honestly, the best way to think about it is like a save point in a video game. After every single action the agent takes, the system takes a complete snapshot of its progress, what it's done, what it knows, and exactly where it is in the overall plan. Now, what's so cool about this is how that simple checkpoint creates this rock-solid, almost bulletproof process. The planner makes a plan, the executor takes just one step, and boom, the state is immediately saved to a checkpoint. Then the system decides what to do next. If the whole thing crashes, no big deal. You don't start from scratch. You just load up that last successful checkpoint and keep going. And this checkpoint system unlocks some, frankly, incredible capabilities. You get time travel, literally the ability to go back in time to a previous state and see what went wrong. You get real fault tolerance. And maybe most importantly, you get a natural, built-in point for a human to step in. The agent can pause, ask for help, get some feedback, and then resume exactly where it left off. This isn't just a feature, you guys. This is a total paradigm shift. And that paradigm shift, well, it's not just some cool technical advantage. It is exactly what businesses need if they're going to ship a real enterprise-grade product. So forget all the philosophy for a minute. Let's talk about compliance. Here's a question every single founder building agents needs to be asking themselves. Because I promise you, if you want to sell to a serious company, their compliance officer is definitely going to ask it for you. And for one of those purely autonomous, probabilistic agents, the answer is almost always going to be no. Let's just break this down. A SOC 2 audit, that requires consistent, repeatable logic. GDPR, that gives users the right to an explanation for any automated decision that affects them. ISO 27001, you have to document how your system manages risk. All of these things, consistency, explainability, auditability, they are a complete nightmare for a black box agent that just kind of chats its way to an answer.
And this says it all, right? Under GDPR, if your agent's decision impacts a real person, the algorithm decided is not a legal defense. You have to be able to explain the logic. With a stateful, checkpointed agent, you have a perfect audit trail of every single step. With a probabilistic one, you've just got a mess.
So, after all that, what's the big takeaway for all the builders out there? What is the pragmatic, real-world path to actually shipping an agent that your customers are going to trust and, actually pay for? Honestly, it's pretty simple. Stop chasing this level 4 God mode agent that tries to solve everything on its own and ends up burning $50 a run before getting stuck. Instead, build a level 3 stateful agent. An agent that's reliable, that saves its work, and that's smart enough to just ask a human for help when it gets confused. That reliability, that control, that is the feature that enterprises are actually lining up to buy. And all this leaves us with one final big question to think about. With all the hype around pure autonomy, maybe, just maybe, we've been chasing the wrong goal all along. Maybe the real revolution isn't building agents that can replace us, but building agents that can reliably and transparently collaborate with us.